Howdy, everybody. Thanks for clicking on such a long video. And if you didn't notice how long the video is, maybe you have now. This is a pretty complicated topic, and I don't think it's one that can be condensed into like a 5-minute video. Um, Not with the depth that I would like to get into. So this whole thing's going to be this Fusion 360 screen recording, a little bit of Notepad, and just me talking the whole time. I've been trying to do this for hours, so hopefully I'll be able to cut together something that's at least somewhat coherent, but bear with me as I make mistakes and do things less efficiently than, theoretically possible. So what I'd like to do in this video is talk about expressions. I'm going to try to avoid droning on about the basics of expressions, but what I want to talk about is inserting if, then, else logic into your expressions so that you can have one expression that basically does two different things for you. Or you could maybe have it like do 10 things, I don't know. I'd say this is pretty advanced, but I guess it could start easy, but it gets advanced. It can easily get advanced, whatever. Without getting into it too much, I think it is worth noting basically what you're going to have Fusion do is just check something. I'm calling it X. You're going to check if X is true or if it's activated. If it is, then it will do one thing. And if it is not, or I guess for all other or for all else, it'll do this other thing. The format that this falls in is you'll have your qualifying question here or statement followed by a question mark. You'll have your output that you want while it's true, colon, and then the output that you want when it's false. When I started messing with these, it seemed like I had to have them within parentheses, but I just tried it again and the parentheses were not necessary. I'm not sure what's going on, but basically most of this I wrote with the assumption that parentheses were necessary, so the parentheses are in most of these things. If something isn't working, even though it should, maybe try putting some parentheses around it just to, see if that fixes it. Okay, so I want to start with some simple stuff, and these are some examples of simple things here. After that, I want to do something more practical. And the practical thing is based on a video that I'll link to up at the corner here, where I created this expression here for calculating an optimal chamfer tip offset. I think this video is pretty cool, but it is also very long, so I would blame you if you don't want to watch it. But basically, if you use this expression as your chamfer tip offset, it'll calculate it and do some cool stuff for you. In that video, I talked about this expression, which helps with doing back chamfers. It sets the axial stock to leave to -2 times this value here. So whatever you put here, this expression will reverse engineer this value and then multiply it by -2. I have not been using this because it kind of causes some problems unless you also combine it with this if then else stuff. So that will be like the more practical side of this video. Or I don't know if it's more practical, but whatever. The part of the video where I'll explain how to implement something practical. Alright. And then later in the video, I would like to get into these, which are some additional expressions that I created. And these mostly deal with leads in and leads out. Either radiuses or linear. And also, here's that axial stock to leave, like the practical example that I was talking about. There's also one more down here that I might get into. This is for changing how a checkbox is checked or not, but it is quite complicated, so we'll see if that ever... We'll see how deep into that I get. Okay, before I get too far into this, I'd like to complain a little bit about Fusion 360. I love it. You know, they give it away. It's hard to complain about that. Don't look a gift horse in the mouth. But I wish there were some things that they would do differently, and, you know, maybe in the future they will. And I can find workarounds. But the way that Fusion handles cam operation defaults is pretty bad in my opinion. I could not personally find any way to back them up, to create a backup, you know, for yourself. Maybe there's some kind of cloud backup solution. I'm not aware of it though. And it is also pretty darn easy to overwrite your defaults in a way that is not, you know, it's not possible to undo it. You can overwrite them with one errant mouse click, and to restore them might take you, you know, 5 minutes of work or 20 minutes of work, whatever. You know, you might never restore them because you've forgotten what you set. So that's a drag. So basically, before getting started on this, I would recommend doing the best you can to backup. If there's a backup solution by the time you're watching this video, I'd recommend doing that. But in the meantime, what I'm going to do is I'm going to create a 2D contour. Everything in this video is going to be based on a 2D contour. So I'm basically going to just, you know, make this output some kind of toolpath that I could then right click on here and protect and suppress. So, you know, this isn't a backup. It's actually a pretty poor example of a, you know, it pales in comparison to a real backup, but at least it's something. So I recommend doing that before going too far into this. Okay, so let's do some easy stuff. I've got a simple example here I think is pretty darn easy to understand, and I can throw it into there pretty quick. It's going to check the tool diameter, and it's going to see if it's greater than this value here, 6.34 millimeters. Anyone who uses metric and imperial will recognize this number as being just a hair under a 1/4 inch. The way this is set up, if this is true, it will spit out 1000 into the field that this expression is put into. If the tool diameter is not greater than 6.34 millimeters, it will spit out 500. So let me copy this and put it into a new 2D contour. I'm going to make this a chamfer. Not that it matters all that much. Okay. So I want to put this expression into this finish feed rate. Okay, so I'll paste it in, I hit OK, and we can sort of infer what the computer thinks based on how it evaluates the expression. So it has spit out 1000, and the 1000 is the value for true. So it thinks this right here is true. It thinks the tool diameter is greater than 6.34 millimeters. And this chamfer tool is a 1/4 inch, 6.35 millimeters. So it is indeed greater than 6.34. So it is set 1000. If I were to change this to equal a 1/4 inch, it now spit out 500. Because 6.35 millimeters is equal to, but it is not greater than 6.35 millimeters. In my opinion, what you want to do here is you want to try to avoid writing your evaluating statement in a way that you get the result, you're basically forcing the result you want. So when I wrote 6.34 millimeters, I was basically just forcing it to do what I wanted. I wasn't writing it in a concise way, in a kind of more accurate way. This is a little better, but it's not actually what I want, because I want this 1/4" tool to go at 1,000. So I don't think I need to get into this too much, but basically what I want to do is I want to have it check if it's greater than or equal to 6.35. Now when I hit OK, it's back to spitting out 1,000, and I'm happy. Hey, once for kicks, take these parentheses away, see if this works. Okay, yeah, it looks like it does. Okay, yeah, maybe the parentheses around if then else are not necessary. I thought they were before, but maybe not now. Okay, so there's one more thing in here that I think is worth changing, and that's this 6.35. 6.35 is the metric equivalent of 1/4", but really what I'm checking here is whether the tool is greater than or equal to 1/4", which is 0.25 inches. I don't think so this will work, so let's hit OK, and we can see the expression has been written out in this field instead of one of the results. That's a bad sign. Fusion 360 is not working correctly right now though, because this should be red right now, but it is not, it is black. Also, if I hit OK, it basically thinks it's fine. In addition to that, I can also right click and hit generate, and it still thinks it's fine. But if I go in and edit this operation again, we can now see that the finished feed rate is red, as it should have been. And if I hit OK, it says failed to evaluate expression. That has highlighted it. Basically, what I think the problem is this value with a unit attached to it needs to be in parentheses. I'm not sure if that's necessarily the case, but with parentheses it works, and without, it turns red when you come back to it. So that's what I was saying about parentheses. If it isn't working, maybe throw some parentheses in there, see what happens. Also, as your expressions get longer, you'll have a lot of nested parenthetical calculations and stuff. So you want to go through and make sure you have the same number of right parentheses as left parentheses. Okay. So, cool. We've got to check in whether the tool is 1/4" or larger, and setting the feed rate accordingly. Another thing we can do, instead of checking numbers, is it can check if things exist or if they're activated. So that's the example I've got here. Basically, you can see it says do chamfer, and it's going to set 0 if this is activated, and 0.1 if it is not activated. So let me copy it and kind of explain that a little further. Okay. Looks like it already sort of was said. I've been recording this video for hours. Okay. So when I am doing chamfering, I like to use this expression here, the one from that video that I put a card to. And that expression basically handles, well, I don't know if the expression does it, but when this checkbox is checked, basically my radial offset is handled by this chamfer width 99 times out of 100. So I would like to change this so that when I'm doing a chamfer, the radial stuck to leave gets set to 0 by default. Okay, so what I wanted to do is check if this chamfer checkbox is checked or not. That is to say, I wanted to check if the checkbox is checked. And if it is checked, this should be 0. If it's not checked, I want this to be my default, which is 0.1. So first I got to ascertain what this is. So I can hold shift, mouse over the checkbox, and on the bottom of that tooltip it says parameter name do chamfer. So I have it checking do chamfer. If it is true, it will spit out 0. If it is not true or activated, it will spit out 0.1. So hit OK. Chamfer is checked, and it has set my radial stuck to leave to 0. It changes axial stuck to leave as well, but that's just because it's matching the radial stuck to leave. So now as I check and uncheck this, the radial stuck to leave is getting switched back and forth between 0 and 0.1, just like I wanted it to, which is pretty cool in my opinion. So I'll hit OK. I wonder what will happen with these at 0. Okay, so that's basically, I would say, the fastest that I can hammer out the real simple stuff. So hopefully you'll stick around and look at some more advanced stuff. Okay, so let's make back chamfering even easier. So I guess I'll create a new back chamfer toolpath. Let me get the right tool. Yeah. I'll come in and look at my chamfering settings. Oh, oops. Okay. Look at my chamfering settings, and I'll see here that it's actually interesting that stuck to leave was checked. Let me uncheck that. Actually, let me start this over. So I want to do that. Okay, stuck to leave shouldn't have been checked here. I guess I gotta mess with my defaults. I plan to kind of show how to do that, but in a separate video, because it's really convoluted. So let me just uncheck this. Okay, so I want to do a back chamfer on here. If you watch my other video, you'll know that basically what I want to do is take this value and insert it as -2 times whatever that value is. -2 times 0.1 is -0.2. I hit OK. And I guess I'll simulate this. I'll just do it this way. You can see the tool is coming down here and is doing its back chamfer, and my 0.1 millimeter buffer is there just like it's supposed to. For more details on that, watch that other video. If I come in here and edit it, sometimes I decided that buffer isn't quite right, or like I want a little more, a little less, whatever it is. I'll come in here and change it. And then I have to remember to then change this one. Let's say I forget. So I'll hit OK. And I'll simulate this. And now it's basically doing a back chamfer, but the tool is you know, the tip of the tool, which is in line with the bottom of this window here, is actually inside of the part. And what'll happen is I'll actually get a little bit of a kind of a really burry, sharp edge thing here, which is no good. So because I forgot to change that thing, I'm now going to have a part with a little flaw in it, a correctable flaw. So I want this to be -2 times my buffer value, which in this case is -0.5. If I do it this way, simulate one more time, and we can see that it is back to doing the proper chamfer, and the buffer is now a little larger, just like it's supposed to. In that other video, I showed how this expression will actually calculate that negative 0.5 or whatever automatically. So now if I come in here and I change this back to my preferred 0.1 millimeter, that expression has updated this and made it negative 0.2. So that's great and all. But if I set this to default and do something that isn't a chamfer, my stock to leave is some kind of a bunch of letters and stuff. That's good. That's have not seen that before. So this expression is fine for doing chamfers, but not so good for other 2D contour stuff. So setting it as the default is not, not ideal. But we now know how to have it check if it's doing a chamfer and do one thing if it is and another thing if it isn't. Pretty cool. So let's apply that to this expression. So I'll start it. I guess I'll leave the parenthesis off this time. Let's see what happens. Do chamfer, question mark. If it is doing a chamfer, I want it to do this expression. If it's not, I had a colon. I want it to do 0.1. That's my preferred default stock to leave value for axial. Well, for both, but anyway. So I'll hit OK. Let's see what we get. Okay, nothing changed. Great. Let's switch the tool back to our end mill. And our stock to leave is not a bunch of words now. It is, my preferred default value. Pretty cool. So let's set that to the default. And just for kicks, let's create a new one and make sure that it works right. Okay, yep, good. So this one is checking if it's a chamfer. If it is, 0. If it's not, 0.1. And this one, it's checking if it's a chamfer. If it is, a bunch of gobbledygook, and if it isn't, 0.1. And just, I guess, since parentheses really aren't necessary, let's take them out and make them the default. Whatever. Okay. Cool. So that was pretty quick. Hopefully it made sense. I am trying to rush through, but also, I've done 3-4 of these 40-minute videos, so I'll move along. All right. So we can have it check multiple things. And when you're checking multiple things, you'll probably want to put an operator, like something, probably this and or the or, into your expression. Well, more than want to, you may be forced to. So it's good to know. These 2 bars is what you put in for or, and 2 ampersands is what you put in for and. 2 equal signs is when you're checking if something is equal. We sort of talked about the greater than, less than is obvious. And exclamation mark equal is when you want to check if something is not equal to some value. I guess for kicks, let's use this one real quick. So was it this one? Let's, instead of checking if it's greater than or equal to 1/4 inch, we'll make it check if it's not equal to 1/4 inch. And just for example's sake, since I, made a big deal about how I supposedly want it to do 1,000 if it's 1/4 inch, let's switch the the value spit out for true or false. So hit OK. So this did not change because this is indeed a 1/4 inch tool. Let's switch over to an 1/8 inch tool. Now our finish feed rate is, you know, since it's something other than 1/4, it does 500 millimeters. You could do something in here referred to as this is a recursive if-then. Okay, so the first thing it does here is it checks if it's a 1/4 inch. If it is, it will do 500. Anything else, it'll do 1,000. Oops, I'm sorry. It is checking if it is not a 1/4 inch. So actually, let me switch this back so I don't keep making that mistake again, or over and over. Okay, so checking if the tool diameter is equal to a 1/4 inch. If it is, set it to 1,000. Everything else will be 500. But it's not necessarily going to be, you know, how you'd really want it to be. So I've got an 1/8 inch tool in here. So what I can do is I can just check if the tool diameter is equal to 1/8 of an inch. And if it is, we'll set the feed rate to, let's say, 500. And for everything else, it will do, it's whatever, 350. Okay. You know, I haven't actually written this out like this without the parentheses in a while, so let's see if this works. Okay, so the 1/8 inch tool, it is doing 500. Let's see, do I have any non-quarters, non-eighths in here? Here's one. What is it? Drill. There we go. Okay, our 1/2 inch tool is doing 350. So, you know, you can get pretty fancy with these expressions. You can also check the type of tool. I guess I'll just mention that I actually don't know how, so it's probably not good for me to try to do it in this video here. Okay. So, that's if you're checking. Oh, right. I just did all that to explain the exclamation mark. Okay, we can also have it check if things like aren't checked. So multiple finishing passes. The parameter name is do multiple finishing passes. Let's mess with the feed rate based on that. Let's just take all of this out. Is it finishing or finish? Multiple finishing passes. Oh, let's do multiple finishing passes. Okay, so I'm going to check that. I'm going to check if it's activated. And if it is, we'll do 777, we got lucky. And if it isn't, 666, we're unlucky. Okay, so multiple finishing passes is not checked. 666. It is checked. 777. Well, sometimes you might want to check if it's not checked. So we can change this and just add an exclamation mark in front. Hit OK, and now it does the opposite function, or the opposite, gives the opposite result, I guess. Okay. What else we got? Oh, and an R. Okay. So we've got multiple finishing passes. Let's say okay. Let's change the Stepover based on how many finishing passes we're doing. So I want to first check if do multiple finishing passes is checked or not. This is basically saying this is activated. You know, is this activated? True. So if that's true, and number of finishing passes is greater than, equal to, or greater than, greater than or equal to, it has to be in that order, 0.2, we'll make it output Stepover of 0.1. Otherwise, it'll do a finishing pass of 0.15. All right, hit OK. Got 2 finishing passes, it's 0.1. Bring it up to 3, remains 1. But take this down to 1. And I guess, what did I do? Oh, I checked if it's 0.2. Okay, less than or equal to 2. Okay, so 1 is set to 0.15. 2 is 0.1. Okay. Okay, so here's a, I don't know, here's a finishing overlap. You know, I'm just messing with stuff here, so let's say we want a larger finishing overlap. If it's doing multiple finishing passes, we want no overlap. Let's say. Or else we want 1. But let's throw an OR in here. So let's say we also don't want an overlap if we're doing repeat finishing passes. So put in 2 bars. And I guess I'm going to just have to guess here because I forgot to check it. Okay, let's leave it at that for a moment. Let's see what this is. Parameter name null pass. I wonder if that's going to work. Well, let's see. Okay, so our finishing overlap is currently set to 1. Check the repeat finishing passes, gets set to 0. Uncheck, back to 1. Multiple finishing passes, 0. Take it off, back to 1. So, you know, you can make a huge list of questions it asks and a huge, you know, plethora of things that it does based on different situations and stuff. Pretty awesome. Okay, did I go through most of the operations here? Yeah, okay. Cool. Let's move on to the kind of more complicated expressions that I made. And they're up here. So I know that if I try to explain these things, I'll be here all day. So let me just show them. Hopefully they're large enough here that you can read. Hopefully you can read them on your phone. I'll scroll this up a little bit so that the bottom isn't cut off so much. So copy these down if you want. Obviously, you know, syntax matters and stuff, so these are working for me. Hopefully they'll work for you. If they don't, double check your spelling and your capitalization, and you know, just go over it. Sometimes going backward 1 by 1 character is an effective way to double check what you've written. Okay. So allow me to just kind of show what all these things do and show why I think they're cool. Okay, so I've got my little sample part here. And let's say that I've drilled this hole. Let's say I'm going to bore this hole out with my 1/4 inch tool. And I want to come back and finish it, so I'm going to give a little bit of stock to leave. Okay, so I'm going to leave 0.1 millimeter of stock. Let's quickly simulate this. Oh, okay, I don't need to do that. Okay, and let's say I want to come back in with the 1/4 inch tool and finish it. So I'll create a 2D contour. I'll select the geometry down there. I personally like to go a little bit below on finishing passes like this. And then, I'm so used to being able to just hit OK. I'll hit OK and whoop, the toolpath didn't didn't get created. It's got a little warning here. The warning says, a contour was not machined because the given lead parameters would cause a collision. I'm sure everyone watching this video up to this point knows what that's saying, but essentially what it's saying is the default lead in and or lead out are too large, and if it was to if it was to use a lead in and lead out that large, it would end up colliding with the stock here, which you don't want to do. So before I started messing with all these expressions, what I'd normally do is I'd come in here and I'd get my horizontal lead in radius and I'd like try something small. Let's say 0.5 millimeter. Usually that works. Why is this not working? Contour is not machined because of given lead parameters. Well, why do things like this have to happen on the... Oh, maybe it's some of this crazy stuff that I put in here. Stock. Oh, here we go. Yeah, it's a stock to leave that I've got to fix. All right. There we go. So it has created the toolpath, and it looks like it might be all right. But if I simulate it, we got the bore, and now the tool is coming down and it's red. And I like to rapid down when doing 2D contours. I have a video about doing that. I'll put up here. I'll link up here. And it's red because it's colliding with the part right here. And unexpected collisions at rapid speed are bad. So, what I might do is I come in here and I change the linking. Maybe I'd change, how much of a angle it's doing. Let's try 60 degree lead in. Okay, yep, still hitting. So, I might then change, this to 0.25 and some super tiny little dumb lead in. And it's just a lot of trial and error. And if you have different size holes, it's a pain. So I've made this little expression to fix that, or at least to make it easier. I don't know if I mentioned this before, so I will now. This is a 7.5 millimeter diameter hole. I'm trying to mill it with that 6.35 millimeter end mill. I mentioned the diameter, but the radius is given to us down here at 3.75 millimeters. The reason I need to know that is that information is necessary to make this expression work. So I have it set to my default. I'll reset this to default. And I guess that's right. I said I was just going to show how this works, so I'll try to make this a little faster. Basically, the way the expression works is it checks the entry sweep, which is this value here, and checks if it's 180. When it is 180, it does all this math in here to give me a super nice lead-in radius. Unfortunately, I can't make a default expression that will handle all sizes of circles. So I have to come in here, and basically what I did is I made this big block of zeros so that they're easy to find, and you can double click on it. And what you got to do is put in the radius of the hole that you're working with. I hit OK. It gives me a horizontal lead-in radius. And when I generate this toolpath, we can see that my end mill is now plunging in the exact center of that hole. Okay, so it plunges in the exact center of the hole, does the lead in. The size of the lead in is the exact, that's the largest radius possible if you want to start in the center. Does the cut of the toolpath, and then does the perfect size lead out to go, to return the tool to the exact center of the hole. Pretty cool. The expression also will handle it if you have radial stock to leave. So I'll hit, I'll turn the radial stock to leave on. It has now, this is now a smaller hole. Let's duplicate it. So I'll have one with stock to leave and one without. That's without, that's with. So we've got two sizes of hole here. And it is leading and retracting in the exact center of the hole, regardless of what stock to leave is selected. It will also account for roughing passes. It will add in this Stepover value. I like to use 0.1. So now, oh, actually, sorry, I've got a kind of another little default thing. Let me uncheck, recheck that. Okay. So now the lead-in radius is perfect, but the lead-out, being the same size as the lead-in, is not leading to the center anymore. That's where this expression comes in. Basically, it has to have its own expression that does not account for roughing passes and stuff. So I'll come in here, I'll put in my 3.75, change this to 180, hit OK. And now we're back to leading in and out from the exact center with the largest radius as possible. We'll also account for multiple finishing passes. If you have those in your operation, and it will also handle the multiple finishing passes without the roughing passes. There are these expressions here. These are for linear lead-ins and leads-out. So if you don't want a radius, what this expression does is it checks the entry sweep if it's 0, and checks the entry perpendicular checkbox. And if both of these are true, then it does the math. So we'll set this to 0. Check that. Come in here. I wish I didn't have to do this, but I don't think there's a workaround for that. Put that in. Another 0. Edit. Okay. So now we've got some linear leads in and out. And it works with roughing passes and stuff too. You can mix and match. Probably, obviously, but you know, maybe you want it to lead. I guess this is leading out with an arc and leading in with a straight line. I guess it's conceivable you might want that. So pretty cool. Let me go back to the lead in. Oops, just the linear lead in. This one also takes into account the vertical lead in radius. So let's just set this at 0.2. Now it comes in, comes in the exact center, does its vertical lead in radius, and then does the remainder of the lead in as a linear fashion, and then does the cuts and leads out, you know, in the opposite way, basically. It would be possible to combine the vertical lead in radius with a horizontal lead in radius, but not with the math tools that are currently present in Fusion 360's CAM expressions. Basically, what you need in here is a JavaScript function called atan and or asyn or acos, and it doesn't have any of those. It has tangent, it has cosine, and has sine, but it does not have the reciprocals of each of those. So I did make it so that you can put in a vertical lead in radius for even if you're using the horizontal. But what it does is it leads in somewhere other than the center, does its vertical, then starts the perfectly calculated horizontal lead in radius. So it's not great, but you know, whatever, it doesn't blow up either, so I guess it could be worse. Okay, this also works with chamfers, including back chamfers. So I'll just kind of put all of these to work now. I guess this, you know, once again with the default stock to leave, we'll do a roughing pass, do a 0.1. Let's just do 2 finishing passes. And basically I've got it automatically deselecting this. So put in the numbers here. Change these to 180. And this is a situation where doing back chamfers is a situation where you'll frequently accidentally run your tool into the side of the part. So having this thing come in the exact center of this hole is pretty nice. You can also use it for like doing undercuts like this here. Yeah, come in the exact center. It's pretty cool in my opinion. I'm pretty happy with it. I look forward to using it. All right, so last couple things, I guess. Okay, I'm gonna put an edit point here. Okay, so last couple things. I've mentioned a couple times how it has apparently set the what is it? Stock to leave checkbox to be checked by default. So let's fix that. Oh, stupid. Okay, whatever, good enough. to change the default of a checkbox, I'm sure a lot of you know this, but what you got to do is right click and go into compare and edit and search for the name of that checkbox. Use stock to leave is set to yes. What I want to do is change that to the built-in default, right click and make that answer the default. So let's delete this, make another one. And okay, stock to leave is not checked, but when I check it, it sets the parameters as I want because it's a chamfer. Pretty awesome. Okay, so one more thing. Should I kept that going? So you're going to chamfer that, and I want to have a roughing pass in there. 0.1. So I've checked roughing pass here, and I've set it up so that when roughing pass is checked, the same as lead in checkbox gets unchecked. So if I uncheck this, the same as lead in then gets checked. So it's saving me like, kind of another step here. I still have to come in and set these radius values. It's a bit of a chore, but I don't have to do any math and there's much less trial and error here. Okay, so how do you make this checkbox respond to an expression? It's actually a lot more difficult than it should be. First, you got to kind of figure out what your expression should be. For this one, it's not too hard. I've got it written right here. I'll just copy it. We'll check the true and false there. And then, you got to right click on here and do compare and edit. Find the thing you want to change, which was same. Edit this. Put in your expression, which I guess is already there because whatever, it's there. But there, look, I pasted it in. I think it's also, I got it in there backward. False, true. True, false. So this actually, this is wrong. Okay. So it would be nice if you could just right click on here and say make default. And I guess for kicks, I'll try it. But I think what'll happen is this will not have defaulted to that. Now, set to that before, so maybe you have a fluke here. Okay, so yeah, now our expression is not what we just tried to make it set to default. It is set to no. And, I'd call this another bug in old Fusion 360. I love you. Bugs are a fact of life. So that's another bug. It is possible to get around it, though. As you saw, I had it in there. So, edit this expression, put it to what I want it to be. Then I'm going to right click on here and hit make all default. Now doing this is going to screw up a lot of stuff, but we can fix it. So hit make all default, I hit OK. We don't care much about this one, but I'll just leave it anyway for some reason. Create a new one. Go into our passes here. Let's see, the chamfers looks okay. Let's see how our stock to leave expressions are doing. All right, so they are back to being stuff that I don't like. So I'll reset this to default, and it is an empty, for when I've made everything in here default, it didn't include these values. So I have to come back into here, get my axial stock to leave. Make that the default. My radial stock to leave. Make that the default. I think the linking may be all screwed up still. Let's reset that to default. Yep. Okay, so fix all of these quickly. Keep doing that. And this will have to be set to 0. Okay, so that's all of the defaults there. What else did it change? This one, I want it to be 0.1. Cool. So now when I create this one, let's do it as default. You can come in here, stock to leave. Okay, that's interesting. I had to tell it to be default, but at least my defaults are saved. You know, progress. Let's check the linking. Okay, so that looks good. Let's turn on roughing passes. This should now be unchecked, which it is. Good. And this, okay. My defaults are at least saved. They just aren't being activated by default. Actually, I put the wrong value in there. Edit, exit, sweep. Okay. Cool. So, you know, pretty long process to change one thing, and maybe it isn't even possible to change two things. It probably is, actually, but it could be a lot better. So, anyone who has any connection to Autodesk might put the fire under them to fix. Cool. So, I think I actually might be done recording this video. Awesome. Thanks for watching. Hopefully this was entertaining and not confusing, and it hasn't broken anything of yours. And if you create something out of this that is useful in another area or even better than what I've done, please let me know in some way, and you know, I'd love to use it or whatever. All right, see ya.